one of the most widely and effectively used food preservation methods in the world today is the freezing method. In recent years, the emergence of fast freezing technologies has been supporting to improve the product quality. Novel freezing methods include high-pressure freezing, ultrasound-assisted freezing, electrically disturbed freezing, and magnetically disturbed freezing. Microwave-assisted freezing and osmodehydrated freezing have been studied. Introduction. In general, all conventional freezing methods have the same drawback as the heat transfer takes place from the outer layer to the inner layer, causing an uneven temperature field inside the food. Outside temperature is lower than inside temperature results in a difference in pressure, and water inside the food tends to move out. The water in food is redistributed due to the movement and freezing process creates numerous fine ice crystals, causing tearing of cell membranes. When thawing, drip is more severe and large ice crystals decrease in volume, reduces the food quality. Thus, in order to ensure food quality, the freezing process must be carried out quickly in the entire food volume, resulting in the restriction of the process of moving water out, so the ice crystals formed in freezing process have smaller size. Schematic diagram of the working principle. The invention refers to a magnetic-assisted freezing system including high-pressure compressors, condensers, heat exchangers, high-pressure thermal expansion valve, low-pressure thermal expansion valves, low-pressure compressors, magnetic transmitters, and the freezer chamber. The high-pressure compressor, the condenser, and the heat exchanger are connected by pipes. The low-pressure compressor, evaporator, and the heat exchanger are connected by pipes. A magnetic transmitter has magnetic coils placed inside a freezer chamber. An evaporator is connected to the freezer chamber through a duct. A controller-connected database is used to control the operation of the freezing system and a magnetic field transmitter through a transmission channel. In addition, the invention also uses a magnetic-assisted cascade freezing method to help shorten the freezing time of food, reduce energy costs, and after frozen food is uniformly frozen. Freezing process and the result of test. Catfish fillet is purchased from local market of Ho Chi Minh City after handling raw material stored at 12 degrees Celsius in the refrigerator before freezing for no more than 1 hour. The catfish fillet is placed on a tray between a transmitter and receiver and is fed into the freezer chamber. The initial temperature of catfish fillet is 12 degrees Celsius and the final temperature to finish the freezing process is minus 18 degrees Celsius in center. 7 thermocouples are attached at the center of fish plate to monitor and record temperature data during the freezing process. All the Vietnamese catfish fillets samples, including frozen ones by the conventional ABF and the innovative MAF, as well as fresh and frozen ones, were analyzed under both two approaches: shear test to determine their hardness, peak shear stress, and compressive test to determine their stringiness and gumminess. By texture profile analysis of catfish fillets for compare under fresh and frozen method, frozen by the conventional air plus freezing with the magnetic fields method, and frozen by the innovation magnetic assisted freezing with magnetic fields method. Hardness cycle 1. MAF has 16.15 Newton higher than 13.65 Newton of ABF. Peak stress. MAF has 53,839 Newton per square meter, higher than 45 503 Newton per square meter of ABF. Springiness, MAF has 1.72 mm higher than 1.63 mm of ABF. Gumminess, MAF has 3.87 Newton higher than 2.25 Newton of ABF. The next three pictures performed between freezing time and center temperature when applied with another static magnetic freezing. Experimental results show that the application of a static magnetic field with a magnetic flux density greater than 400 Gauss helps reduce the freezing time of the catfish fillet. The freezing time was reduced from 35% to 38% at freezing temperature minus 30 degrees Celsius, from 35% to 51% at freezing temperature minus 35 degrees Celsius, and from 49% to 57% at freezing temperature minus 40 degrees Celsius. Conclusion. The invention achieves a freezing system and a magnetic-assisted freezing method that can provide fast freezing rates with the help of the magnetic field, helping food with good quality, increasing storage time, reducing the cost of energy. Patent applications of the development of household refrigeration products such as refrigerator, freezers, and coolers follow the trend of providing high-quality frozen products. These evidences and findings could provide support and drive further the research and applying the innovative freezing processes and technologies as magnetic-assisted freezing process to improve the final structural quality of Vietnamese catfish fillet products and other food products. We are Nguyễn Thị Tâm Thanh and Phạm Quang Phú from Industrial University of Ho Chi Minh City, Đỗ Quang Khánh from Ho Chi Minh City University of Technology. Thanks for watching.